A police officer responds to a call by first traveling in a straight line down Dodge Street until he was 15 miles west and 8 miles north of the police station, which begs the question, shouldn't there be another police station closer? Anyways, then he turned onto Grandview Avenue and traveled in a straight line until he was 3 miles west and 13 miles north of the police station. And finally, he turned on Kane Street and traveled in a straight line until he reached his destination, which was 6 miles west and 17 miles north of the police station. I don't know about you, but man, that's a lot to remember. So I can't. So I'm going to draw this out. And my directions might be a little off, so I can fit everything into here, but you'll get the idea. So our first thing is we go from the police station, and we go 15 miles west and 8 miles north. Okay, so I'm going to say the police station is right here. I will call the police station PS for police station. And I'm going to go 15 miles west and 8 miles north. So I'm going to go north first. So 1, 2, 3, 4, 5, 6, 7, 8, and 15 over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I will connect the dots because we drove in a straight line. There we go. And so we have 15, we have 8 and 15. And so I know this is a Pythagorean triple, 8, 15, 17, but we're going to use our a squared plus b squared is equal to c squared. And so a squared is 8 squared, which is 64, plus b squared, which is 15 squared, which is 225, which is equal to c squared. I add these two together, and I get 269 is equal to c squared. I take the square root, and c is equal to 17. So he drove 17 miles to start with. Then he turned onto Grandview Avenue and traveled in a straight line until he was 3 miles west and 13 miles north of the police station. So again, we're dealing with our police station here. So 13 miles north, well, here's 8, 9, 10, 11, 12, 13. Oh my gosh, I wish I could say I planned that, but I didn't. And 3 miles west. 1, 2, 3. And so now we have a new triangle. And so this height is, 1, 2, 3, 4, 5. This distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a 5, 12, 13 triangle, but you don't have to take my word for it. We can do a squared plus b squared is equal to c squared. And so we have 25, which is a squared, plus 12 squared, which is 144, which is equal to c squared. So we have 169 is equal to c squared. Take the square root, and we get 13. It's amazing. It's nice when everything works out nice and even with no decimals. And so then finally, he turned on Kane Street and traveled in a straight line until he reached his destination, which was 6 miles west and 17 miles north of the police station. Great. I don't have 17 lines. I'm at 13, right? So 13, 14, 15, 16, 17. And we are 6 miles west. So 1, 2, 3, 4, 5, 6. So I'm going to put a dot here. And so we went from 13 to 17, which is 4. We went from, I'll just count. 1. Oh shoot. He was 6 miles west of the police station. Or 6... Yeah, so we're 6 from here, sorry. 1, 2, 3, 4, 5, 6. So he was 17 and 6. I messed up. So my mistake was using the distances as they were stated from my original point instead of going back to my reference point, police station. So here we have 17, so this is still a difference of 4. I went 1, 2, 3 over. Oh, this is nothing more than a 3, 4, 5 right triangle. And I know we've talked about that, so I'm not going to do the Pythagorean theorem. So then, how many miles did he travel on Dodge Street? That's our first trip, which is 17. For part 2, how many miles east and how many miles north of the intersection of Dodge Street and Grand Avenue is the intersection of how many miles did the police car travel? So that's the 5 and the 12, and then the distance he traveled is your 13. And finally, how many miles, and most importantly, how far did he travel in all from the police station? So we have our 17, 13 for 30. So he traveled a total of 35 miles. How far is he from the police station? I'm not sure that's what they're asking. So that is a kind of an interesting way to look at a Pythagorean theorem problem.